Okay, so here we are. We have this layout, and what we have to do, we have to first, we can draw or we can start measuring things first, or we can start by measuring or by taking the drainage fixture units. So here we have sinks and we have toilets. So in this table, the water closet, it's a public. In Revit, I think we use this one because that's the only toilet that we have in Revit. So we can take this, we can take 10 fixture units for toilets. And for the sinks, for the lavatories, total fixture units, we can take 2. Okay, so here we have cold water and hot water. Okay, so we have 1. See? So this is the lavatory, closet. Okay, so apparently we have one half for the hot water, and okay, so for the sinks, and we have one half for the bowl, and one half for the hot water. Okay, so if we have this, what do we have to type here? I'm going to insert text, so I can insert 10 fixture units per toilet. So I'm changing the font. Okay, so we have 10. Fixture units here. And for the, let's start with the cold water. So here we will have one half. Let's say 1.5 fixture units. $1.5. Okay, so now what's the minimum branch that we have for toilets and for the sinks? So it's here, the minimum for the water closet, we have this one. So the minimum, it's 1 inch. Okay, so for 10 fixture units, the size or diameter is 1 inch. And for the other, for the lavatory, it's 3/8, not 3/4. Okay, so this is 3/8. Am I correct? Yes. So we are taking this lavatory, and this is 3/8. But if you have taken something different, that's fine. Okay. If you have taken another water closet, as long as you show this table, and probably if you are going to submit something like this, you have to select here the element that you have taken. Okay, if you do something like this, now I can understand that this belongs to the table. But if you take the other public, this is a public water closet, and there are 2 different. Yeah, so this is the public one. Okay, I have taken this 10 because it's what we had in Revit. But if you take the other one, which is only 5, that's fine. Again, if you are doing this and if you have a 20-year experience working with this, you will understand if 10 it's better than 5. Because if you select 5 for your first one and there are issues with the, okay, this is not working well. So because, and the pipe has to be thicker because there's a jam and every other year we have to remove this and there. Okay, so next time I will select something bigger because you can save a lot of problems. But so far, if we have these 2 options in the table, either option is good. So we have selected this, and then for the other one, for the lavatories, we have selected this option. So what's next? Now we have to decide the length of the pipes. And yeah, so here we have different options. And we don't have, here we don't have dimensions because it's there. You can go and you can measure it. And if you don't know, if you don't need a tape, you don't need that. And that's another important thing that you have to understand. You have to measure. Sometimes we have to, again, we have to make quick decisions. We don't have a tape or we don't have a digital meter. Nowadays, oh, I don't have a digital meter. I don't know what this height because I don't have a digital meter. So how can I find out this? And well, no, I have to go to my home, but then I have a meeting. Yeah, I'll be back tomorrow. Tomorrow? To let me know the height of this ceiling. Come on, we have to be resourceful. And this is what people and architects we have been doing for forever, since Vitruvius, 2000 years ago. It's using our body to measure things. So if, how many? 1, 2, 3, 4. This is the basic thing. So what's the size of this? Here you see that we have like joints. What's the size of this between these 2 joints? 1, 2, 3, 4 steps. So I know my step. I know the distance in metric. It's around 3 feet. Okay, so if this is 3 feet, so this is around 12 feet, kind of. And if I know that this is 12 feet, well, and I know I know my body, so I know this distance. It's 2 meters and 22 centimeters. I know. Okay, so this is 2 meters and 22 centimeters, which is almost double. So I can figure out the height of this. Maybe I'm wrong in a few inches or something like that, but again, a few inches doesn't affect these calculations. Okay, so what's this? Do we have any reference for dimensions? When you have a door, doors always have the same measure. Okay, so what's the thickness? What's the width of a door? 3 feet. Yeah, and 3 is a magical number. Everything's 3 feet. A step is a door is 3 feet. Okay. If you have stairs, the horizontal part of the stair is 1 foot. Okay, so there are things that when you're reading plans, you can have this kind of measurements. And yeah, you can make a mistake 1 inch, 2 inches, but nobody will notice. So if we have this door, this is around 3 feet. Okay, so if this is 3 feet, depending on the layout of the pipes, but I can get by with that. And now, what's the layout? I don't know. So something has to be good enough. Okay, so if we create arrows, usually when we have a hallway, things are going through the hallway. Okay, so the building, the water supply will be somewhere outside the building. I told you that most likely it will be in this in the parking lot, like it's over there. So there will be one of those caps that we see on that parking lot. I'm sure that it's the city water, cold water supply or whatever. Okay, so that will be the first point in which we have to measure that. And then probably it will go somewhere, there will be a vertical pipe, it will go through the false ceiling, the first floor, and then we'll go up, and then we'll go to the through the false ceiling to the second floor. And usually it will go through the hallway, usually. So when we have a hallway, all the pipes usually go through the hallway. In this case, it's not like that because those ducts are going through this. We don't do that, okay? But that's another question. Anyway, if we make that kind of decision, again, if we have a hallway, most likely it will go there. Does it make any sense that the pipes go through the meeting room, then they pierce this double wall, and then they go here, and then they go again? It doesn't make sense. It's possible, but going through the hallway, I think it's a better option. So let's make it like this, and then I'm doing this because I've done this before, and I don't know, I haven't checked the piping of this building. It's somewhere. I think Cartis has all the technical plans there. So if you are curious, you can do that. But I don't mind the real one. Okay, but probably I will go in this direction, and then I'll go like this. Up to the toilet. And probably here, there's another branch. And then we go this way. Okay, is it possible? Yeah, if you have decided that you go this way, and then you enter the restroom in this direction, and then you go this way and that way. Okay, that's fine. But, well, sometimes if we have a door, because here we might need a valve. So every time we enter a restroom or a room in which we have a toilet or sinks or whatever, we will have a shut-off valve entering the room. Okay, so the shut-off valve in this case, I think it will be here. Okay, if something goes wrong in this restroom, so I can shut off this valve, and then the rest of the building works well. And okay, so if the problem is here, then I can just isolate the issue, and it doesn't affect the rest of the building. Okay, so I think the shut off valve, and at the entrance of every restroom, we have this. If you have decided that this pipe enters the restroom here, the shut-off valve, it will be here, and it has to be accessible. So those shut-off valves, usually, if you take a look at it, it should be accessible. Probably, if you don't find this, it's not in the false ceiling because it will be too difficult. So this is something that probably it's in the janitor's room that we have in this area. I don't know, but it's something that it's very easy to understand where this is. And if there's an issue, you call maintenance, and maintenance, they shut off dissolve immediately. They don't have to remove the tiles of the false ceiling to find this. So it should be accessible. And if there's a mechanical room or there's a janitor room, probably it's there. But if, in some public buildings, you can notice, oh, so there are two things here, one for the cold and one for the hot water. Anyway, what's next? Oh, please. So we have the branch going to the toilet. So what's the size of that branch? What's the size of that branch?
1 inch.
1 inch. Okay. So this is 1 inch. And all the toilets, they have the same branch here, 1 inch. 1. And 1 inch. Okay. 1 inch, because we have made that decision. We have selected this 10 fixture unit toilet, and the minimum branch for this is 1 inch. Then for the sinks, what is the size of this branch for the sinks? 3/8. Oh, this is 3. Yeah. Three eighths. Now I select this. Creates. And 3/8. Okay. And now we have to apply the rule of thumb. If we have 4 3/8 here, what is that? I mean, here we have 3/8, 1, 2, 3, 4. What would be the size of that one? 1 inch. What? Yeah, so there is not. We have this rule of thumbs, and I think it's more than the 10, 1/4, or 1/2, more than, I don't know how many. Okay, let's look at this rule of thumb. I wrote this rule of thumb, but now I don't remember. So let's go to the lesson. Okay, so here we have up to 3/4 or up to 6 1/2. We can have a 1 inch main. Up to 5 3/4 or up to 10, it can be 1 1/4. Did you stand your ground? So you still think that it's 1? Yes. Yes. Okay. Yeah, I don't know. It can be either 1 inch or 1 1/4. So what's the difference? 1 1/4 is slightly more expensive because it has more material. 1 inch probably it's enough. Okay, so this is up to us. If you, but again, the wrong decision would be if we have 3/8 here, and suddenly this is 1/2. This is completely wrong. And even if this is 3/8, I wouldn't be so sure. Okay? But if it's 1 inch or 1/1/4, I don't know. Okay, so let's. I'll do what you say. If we have any issues with this, it will be your responsibility. So this is 1 inch. Okay, perfect. It could be 1/1/4. It could be, yes. But if the really wrong thing is that if this is 3/8 and this is 1/2, then that would be impossible. Okay, because we have to. When we are approaching to the main pipe, the pipe has to get thicker and thicker. Or when we are approaching the last fixture, the pipe has to get thinner and thinner. Okay, so that's the only rule that we have to follow. So this can be 1 inch. Here, this one can't be 1 inch because here we have 5 1 inch branches here. So what would be that one? What would you say? One half. Yes, I would say 1.5, 1/1/4. Maybe it's not, but to be on the safe side, I would say 1 and 1/2. Then we have to check this. Okay, so we are making those decisions, and then we have to check at the end if those decisions that we have made are good or not. But let's do this. Okay, so we have 1/1/2, and then we have this one. Okay, so we have this branch. So probably in this branch after the first, and this is something that plumbers usually don't do. Okay, so I wouldn't do this. Okay, so after this we have 1/1/4, and then after that we have 1/1/4, and then after that we have 1 inch. And then after that, we have 1 inch. Okay, we can do this, and probably this is something that architects or people working in the office, people that are not on site, this is the kind of it's not a mistake. This is the kind of decisions that we make. Well, for plumbers, every time they have to reduce the pipe, you need a reduction, and it's more work, it's more material, and it's more money. So plumbers probably they don't pay attention to this. Okay, so you are telling me that this is 1/1/2, then I have to go to 1/1/4, and then to 1. Yeah, because that's the last one is 1, so it makes sense that this one. Here we don't have any branch, so it's 1 inch, it can be 1 inch. If we add 2, probably 1 inch is enough, but if we add the third one, probably it's 1/1/4, and then if we add the fifth one, there's 1/1/2. Probably if I were the plumber, I would decide that, okay, let's make everything 1/1/4, and I don't work more than necessary, because 1/1/4, it will be enough. Remember that what we are deciding, it's the minimum size or the minimum diameter of those pipes. It can be slightly more. It would be another mistake if we type here 2 inches. That makes sense. 2 inches, because 1/1/4 will be enough, or 1/1/2 maximum. Okay. Or you can know every single from here to here, it has to be 1/1/2. From here to here, 1/1/4. From here to here, 1. Plumbers usually don't like this. Okay, so they prefer, okay, so I fix this element, and then I get, or I have these branches going to the toilet. So probably that would be what I would do if I were the plumber. I have been a plumber, by the way, a high standard plumber, but I have done this and I learned a lot. Okay. And I learned that this is not what I wanted to be, but I learned it by doing these kind of things. So yeah, it's good. But even with different numbers, it would have been correct as well. Okay, but as long as you don't make it. And what is the mistake? If we have this 1/1/2. This has to be smaller, and this has to be the smallest one, okay? If this is 3/8, this has to be bigger. And now we have this one. If we connect 1/1/2 and this 1 inch, probably at least this has to be 1/1/2 minimum. If, okay, can it be 1 3/4? Probably, well, maybe. But at least this one has to be 1/1/2. If you type here 1 inch, that would be a mistake because here we have a 1/1/2 inch here. Okay. And now the question is about that one. Because that one, remember that here we have two restrooms. So we have the hallway, and we have 2 restrooms here, so we can have the main, and then we go in this direction, and then we can enter the main restroom here. So probably here we have 1/1/2, and for this restroom probably we will have 1/1/2 too. So this I would make 1 3/4. Taking into account that we have 2 restrooms here on this floor. So again, minimum, and I can understand that if you, okay, I haven't considered the other one. Well, this is our building, so we know that there's another restroom on this one. And most likely there will be another branch going in this section. So this 5, I would make it 1 3/4. But because I have considered that here we have another one, okay, another restroom. So that would be 1 3/4. Okay, so that would be good for the cold water. I'm not doing the hot water because the hot water is easier. Probably there will be a main branch here for hot water. Through the same hallway. The only thing is that that would be a red one. Okay. And now we don't go to the toilets. There, the hot water, it's only here. There's another shut off valve here at the entrance, and then it goes only to the sinks. So for the sink, the 1/2 hot water, I think it would be 3/8 as well. So it would be easier than that. So here we will have 3/8. That will be 1 for the hot water. And if we go here, if we connect to 1 inch pipes for this restroom and for the other one, this can be 1 1/4, 1 1/2 maximum. But the cold water, it will be thicker because we have the toilets and we don't have toilets for hot water, okay? So that's possible. So we can do this layout. Now, the big question, what is the length? Again, we have to, so if we have, and usually for this, it's better. And in Revit, we do have the drawing. But here we'll say, okay, so if this is the cold water supply, this is the city supply. Where is it? Where's the distance between the city to the entrance of the building? I don't know. It can be 5 feet or 1 foot or whatever. And then there will be a vertical pipe going up. we have two floors. So this is 50 and 50, or around 30. And then we go through the hallway. And then through the hallway, we go in this direction. And we go in that direction. And apparently, the furthest picture, it would be the toilet that we have here. Okay, so I think it would be this toilet or this sink. Kind of, okay. And now let's well, we have 10 because I have decided that from the city to the entrance to the building is like 10 feet. Then I have 30. And if this is not 30 or close to 30, it can be 28 or 32 or whatever. But if you type here 10, that's wrong because the height, we know the height, there are 2 floors and it's around 15 feet. Okay, so 10, 15, 15, and then we have to go all this way. So what's the distance between the entrance to the building up to the entrance to this direction? I don't know. If this is 3 feet, 3, 6. So this is around 6, 12, 18. And I don't know, now I don't remember the distance. Okay, so let's say that 30 feet, or 30, let's say 32. And okay, it can be 30, 32, but not 5 or 4, or not 100. Okay, so it has to be something from the entrance to the building until the entrance to the restrooms. And now this distance, if this is 3, we'll have 6, 12 here, and 6, 12. Okay, so this is around 24, 30. Let's say 12 here and 15 here, and then we have to go down. So we go down from 15 feet up to this. Okay, so this can be 10. So what's the maximum length? Yes, 109. It can be 110, 187, 150, but around 100. Okay. So if we have this, then we have to analyze this table here. Okay, so what do we have to do? The maximum developed length. The maximum developed length is this number times 0.2. Okay, so the maximum developed length is 109 times 0.2. Then what else we have to? It's the maximum developed length. Then we need the pressure. So that depends on the height. And then we need the maximum, the number of fixtures that we have here. How many fixtures do we have? We have the 10 times 5 toilets, so this is 50, and we have 4 sinks times 1.5, and this is the sink. Okay, so do we have 56 fixtures? Do you have that number? Because that number should be for all of you. Do we have 56? Okay. If you have taken different fixtures for the toilet or for the sink, it might be different. But in this case, if we have 5 toilets times 10, it should be 50. And if we have 4 sinks times 1.5 or 1/2, it should be 6. So we have 56. And we are always in this part of the table because that depends on the height. Okay. So there's a formula here. So it's the static pressure So we can say that 65 PSI, it's the pressure that we get from the city. If I don't say anything, you can take 65 because this is something standard in all the cities in the area. And then if we take this one, 0.433 times that, but once you have done a building with 2 floors, with 30 feet, you know that we are always going to be in this part of the table between 45 to 60, okay? So we don't have to do it again because we have already done probably everything that goes from 2 floors to 4 or 5 floors. We will be here from 45 to 60. And then we can go here or over 60. Probably for 1 floor, it would be over 60 because we have only 1 floor. But, okay, most likely in a 2-floor building, we will be here in this table. In a 2 or 3-floor building, we will be in this table. And then what do we have to check here? We have to check the maximum developed length. The maximum developed length is 109 times 1.2. It's 130. So again, if it's 100, it's not enough. So we have to be in this column, 150. Then the number of fixtures is 56. 52 is not the option. We have to go to the following one, 80. And we are in this part of the table. So that would be 1/1/2 would be the maximum. Well, no, I don't agree. I'm making a mistake. If we only had this toilet or this restroom, sorry, 1/1/2 would be the right solution. So we have to go back here. And what have we said? So this is 1/3. Okay, if this is 1/3, then this is not the right value. Because 1/3 is more than 1/1/2. And we're always talking about the minimum size. Okay, so that would be the minimum size for this restroom. But we have made those decisions, and here we have 1/1/2, and we have decided that when we connect 1 inch and 1/1/2 inch, the result is 1/3. We have made that decision. Okay, so now we can go back. If we have this table, we can't say that this connection is 1/1/2, but 1/1/2 is less than 1/3. Okay, so our solution for this, it's 1/3. So with this table, we check our decisions. We have made decisions, and probably if at the end of this, we had decided that this branch can be 1 inch, then we will have to change it because according to the table, this is 1/1/2. Okay, so you get the point here. We have made those decisions first, and making those decisions, we have decided that this is 1/3. The minimum should be 1/1/2 according to the table. If we make those decisions, and after all this, we decide that this is 1 inch, and according to the table is 1/1/2, then we have to change to the table value. Okay, so we're doing this without the table. So we have decided the fixtures and just common sense. Okay, so this one can be 1/4. If we connect the 5 toilets, this can be 1/2. And then there's another branch here, 1 and 1/2. Okay, let's make it 1/3. Fine. If we go to the table and this is 1/2, okay, I keep my decisions 1/3. If after making all this, I say, okay, I'm connecting 1, 2, 3, 4, 5 branches of 1 inch. Well, let's say that it's 1/4. And I have 1/4, 1, one person, one. Okay, so I keep my, this is one four. And then the table, we find that this is one half, then we have to change to one half. Okay. But I'm going to consider something different because I have a 56 fixture unit. So we don't have anything here. So for me, this 5 is 1 3/4. Okay. But now remember that I have another restroom here, and I have another restroom there, and I have another restroom on the first floor. So at the end, I have 4 different restrooms. Okay. So what's the size of this first pipe that comes from the city supply? Because we have to supply water not only to this restroom, but to 4 of them. Okay, so now things change because what's the number, the total number of fixture units? Okay, so now I have a vertical pipe and I have restroom 1 with 56 fixture units. The second, the third, and the 4th. Okay, so I have 4 restrooms, and if I decide I haven't done well, I think we did the gentleman restrooms last week, but I don't remember. But the fixture units should be around 50, 56, or 60, something like that. Okay, so here, what's the minimum size of this first pipe? So I have to add all these up. So it's 56 times 4. 122 fixture units. So here we have 222 fixture units in this pipe. And what's the maximum developed length? Okay, so we have to change the table here. So now with the same maximum developed length, now it's 222. So we have to move this to 235. Okay, so here what it says is that this branch should be 2 inches. Minimum. Does it make sense? Yeah, I have decided that this is 1 3/4. I will have another one with 1 3/4. So if I connect at least 4 1 3/4 minimum, this should be 2 inches. Okay, so that should be 2 inches. And then this vertical one would be 2 inches. It should be 1 3/4. This would be 1 3/4. This branch that goes to the flat restaurant. This would be 1 3/4. It would be 1 3/4, and the vertical pipe would be 1 3/4. And then one here in this restroom. I think that was well, there was another branch here, but this is the when we are out of the toilet. This is what we have. The minimum from the city supply. The first pipe, the minimum should be 2 inches. Any questions? Okay, we'll do it again. On Friday, we will keep working with Revit, but I want you to do this because you have different layouts. So the maximum length will be different for each student because it's impossible that you have exactly the same length because you have done it on your own file. And we have 2 floors. We have 4 different restrooms, 2 on the first floor, 2 on the second floor. So that's the goal. The goal is that we need to dimension the first pipe that comes from the city supply. And then we have to take into account the maximum developed length and all the feature units that we have in all the restrooms. So we will do this again on Friday using your Revit file. Okay, but believe me, I bet that it's going to be 2 inches because as you can see, 2 inches is the maximum. Okay. The only thing we have to check if 2 inches is enough because I don't know how many. I think we have something like that. We have like 3 or 4 toilets and sinks. Okay, so it should be something similar to this. So when you have designed this building, now the building that you are working with Revit, well, that's the second time. This is the first time you're doing this. The second time will be on Friday with your Revit file. But every time that you are designing a 2-floor building with 4 restrooms, male and female, with 5 toilets or sinks, something like that, what's the pipe that comes from the city supply? 2 inches. Yeah, well, if we're not sure, yeah, we can check it. Okay, let's see. Oh, because here we don't have 5 toilets. We have in each restroom, we have 10 toilets and 10 sinks, and we have 4 floors. Okay, do it. But for 2-floor buildings with 4 restrooms, 2 inches. So I bet that the final result of your Revit file will be 2 inches. Okay, so if you haven't done this in Revit yet, you can start with the main branch with 2 inches, and then you won't have to change it. Okay, this is it. I'm not going to do the hot water, and the hot water is going to be less than 2 inches because we have fewer fixture units. We only have the 4 sinks in each restroom. Okay, so we have 6 times 4. So probably the main duct for the hot water supply will be much smaller than this one. So now we are going to dive into the amazing world of drainage. This is the assignment. Yes. There you go. Drainage, again, it's not the most exciting part of the building, but it's necessary, okay? So buildings are like bodies. We have beautiful things and we have things that we're not very proud of. But well, if the things that we're not very proud of start failing, our life becomes miserable, okay? So the same thing happens to buildings. You can have an outstanding building. Oh, it's beautiful. Yeah, but you flush the toilet and it doesn't go down. Something's wrong with it. Okay. So drainage, we have to hide it. Well, here we can see the drainage pipe, but I wouldn't do that. I don't mind looking at ducts, water supply pipes. I don't mind, but I don't like having a drainage pipe here, especially if there is a leak. It's something disgusting. Okay, so it's better I would hide it, but again, that's the architect's decision. And we have to make sure that everything goes well. We have to make sure that we have fewer connections, and we have a minimum amount of elbows and tees and all that stuff. Okay, so the best drainage is the most straightforward, and that depends on the amount of vertical pipes or vertical stacks that we have in the draining system. So in terms of working well, the more stacks, the more vertical pipes, the better. But they take up a lot of space, and having a lot of vertical pipes in a building, it might affect the design of the building. But so again, we have to balance the amount of vertical stacks that we have, and because the more the better. But again, having a lot of stacks going up and down, and remember, the key thing here is that when we have drainage or a sanitary system, we have a stack that goes down, but we have a vent that goes up. Okay, so and without that vent, that can't work. So that's the first thing that you have to keep in mind. We all understand that it has to go down, but remember that it has to go up because the air has to enter this, and it's the air that is moving the all the way. So this is a typical bathroom thing. Okay, so we have a toilet. We have slope. So the minimum slope is 1/4 inch per foot. Okay, so that's the minimum slope. What does it mean? That means that if we are using a drainage pipe, so we need a slope, and the slope has to be minimum 1/4 0.25 inches per foot. A foot is 12 inches. Okay, so that's the minimum slope, and this is the minimum. It can be more. Okay, if this is 12 inches, we have to make sure that the height of this pipe is 0.25 inches. Okay, so we need a slope. When we are designing this kind of elements, we do have a slope. If we have 12 inches and the difference of height between the starting point and the final point is 1/4 inch, what would be if we have this, but instead of 12 inches here, we have 12 feet? What's the height difference? Hmm? 3. I have to convert this to meters, and then I have to get that. Okay, so 12 feet would be some 4 meters. Yeah, I think so. It's 3 inches. Okay, so that means 12 feet. We decided that this is around 12 feet. So this is 3, 6, 9. Yeah, so this is around 12 feet. So from this point to that point, there's a difference of 3 feet. Okay. And so here we have a slope, and we should have a slope. So this is more than 12 feet. So probably there's a difference of more than 3 inches between that point and that point. Okay. We can tell that slope is so, yes, so probably it's not like going like this. It's not a very steep slope, but it has to exist. If it doesn't exist, and the worst thing that can happen with the drainage is, so we can have a slope that it's less than that. But if for some reason we do something like this, that's a terrible mistake. Okay, so if we make a mistake or the workers make a mistake and we have something like that, that's nothing. So there will be jam, and if we have jams, probably there will be eventually there will be a leak here. If this doesn't move, well, something terrible will happen. Okay, so again, make sure that everything goes, and if you have connections, make sure that the connections are in this direction. Connections are important. When we are talking about drainage, is this acceptable? Why? Check it out. No, this is horizontal. So and we are looking at the floor plan of the layout. So it's not vertical, but we are looking horizontally at this layout. What would you say? Two of those run into each other. No way. Okay. So that goes in this direction, and that goes in that direction. There will be a jam here. Okay. So all these connections have to follow the natural flow of the sheet. Okay. Even a perpendicular connection, it wouldn't be quite good. Okay, so this is not good enough. Here we have a perpendicular that you see that this elbow is not completely perpendicular. So we always have this 45 degrees between these two pipes. Okay, so we don't have elbows with 45 degrees. We don't have elbows. We do, because here we do have an elbow, and I think it's 45 degrees. Yeah, so there in this connection, we have an elbow like this. I think it's better if we go like this. That's better. Okay, so we have a connection, and this connection is a 45 degree connection. This is better than this. Okay, so this part of the pipe, I think it's better. In that part of the pipe, it's not as good, but well, it can happen. We have there we have a connection like that, but then they have extended this, and they can remove this. Is like a cap. They can remove this cap, and in the event of a jam somewhere, they can take this off, and then they can inspect, or they can look through this to see where the jam is. So in horizontal parts of this piping system, we have to be very careful, because we need a lot of elements like that, so that I can, if there's a jam, we have to identify where the jam is immediately. So we need a lot of elements like this in which we can remove this. Okay, where is it? And you look at this. Oh, it's over there. Okay, so let's replace that part of the pipe, because okay. So connections always like this, vertically and horizontally. Okay, so even if we have a vertical connection, Okay, if we go vertically, when we want to get to the horizontal pipe, this is better. Okay. Do not have an angle like that. So that's better. And there's something else very disgusting in drainage systems, especially when we have vertical stacks. Okay, so imagine that we have a vertical and we have different floors here. We have the floor, well, in this case, it's like this. Okay, so that comes from a restroom. And then there's a second floor here. And then there's a third floor here. And here we are underground. And we go out of the building. Well, the most likely element to have problems is this one, because the sheet is very heavy. Okay, so if you go that way, let's make it even better. Okay, so I told you that when we have this connection, then here we change slightly, we change the angle that way so that we facilitate the movement. Okay, so that's perfect. Here we have something horizontal. We change the angle here to get to the vertical one. Okay, that's good. What happens here? All the sheet is falling from, if this is 15, 30 feet. So the weight that we end up having here, it's a lot because it's moving through the gravity. So it's very likely that after some time that breaks and we have a leak there. So be careful with the connection between this vertical stack and the main horizontal branch. If this is underground, it's quite easy because we can always reinforce this here. Okay, so we can have something solid so that this impact fall. So we have something solid here, and then that will happen. But when we have, especially in parking lot, we don't get to the underground. We just have the main horizontal branch hanging from the ceiling. So this is a very important part, and we have to reinforce that, and we need a lot of hangers to make sure that, okay, so here you see that we have something that is connected to the ceiling, this element there, you see? When we have a connection with a vertical pipe, this connection has to be very strong because otherwise it doesn't happen the first time. It doesn't happen the second time. It doesn't happen the first year or the second year, but eventually, if this is hanging and this connection is not very strong, after 5-6 years, it will break. Okay, and don't underestimate the importance of this, of the weight of water and heat moving down. So this connection between the main stack and the main horizontal branch, it has to be very, very strong so that we avoid this excess of weight that we have here. Because this is not just a weight, and that's the nature of structures. So we can break something. Okay, and this can be like beam or columns or whatever. If we have a weight here in the middle, we can break this by making this weight very heavy. Okay, so we exceed the tension that this material can bear, and then it breaks. Okay, that's intuitive. Okay, I want to break this table. So I start putting weights here, and then eventually will collapse. But something can collapse just by applying a small weight many times. Okay, so if I start doing this with the table, after, I don't know how many, probably my hand will break before, but after doing this thousands of times, the table will break because you have applied a very small weight, but multiple times. Boom, boom, boom. So this is what happens here. Okay, so it's not continuously, so this weight is not a continuous thing. So when you flash, boom, and this I flash, boom. Okay, so doing this, applying small weights multiple times, it's even more dangerous than having a big weight that is constant. Okay, so that's the thing. This is good because here we have a connection between something vertical and something horizontal. So we have this here, another connection between something horizontal and something vertical. So we have this is not a T. It's a T, but this thing it's like a curve that way. Here we have a T, and there we have a T here, and not something like that. Okay, because here is water going down, but this is the vent, so it's air, so we don't need that movement because we don't have weight there. Okay, so we need the vent. Is it necessary connecting this vent to the sink? I wouldn't do it, okay? But it's safer. So we have a vent to the main horizontal branch, and we have a vent to this secondary horizontal branch. It will work better, and probably there is the likelihood of having a jam here is less here, but it takes up a lot of space. Okay, so sometimes we see things that that's perfect. We have a vent connected to every single element, to every single fixture. Sometimes we can't do that. Okay, so we definitely need a vent, something that goes beyond the roof, connected to the main horizontal branch, but we don't have to connect all these vents to all the horizontal branches that we have in a restaurant. Traps. We spoke about traps on Friday. They are very important for everything. And this is a breakthrough in history of mankind. Believe me. And so we have this trap, and when we apply water here with the pressure that comes from the tap, the water moves in this direction. And when we stop the flow, the water stays here. So that's why the design of this trap, it's not anything. So, but now you can go and buy traps in Home Depot, and you don't have to worry about the design because they work. Okay, so here, this is interesting, and this is something that, well, it's half good, but it's not well solved. Nowadays, I think in most of the towns or most of the cities, we have to separate the black water and the gray water. So what is black water? Everything that comes from the toilet is black water. And sometimes everything that usually they consider the water that comes from the shower, again, as or bathtub as black water, because it's in touch with the human fluids. Okay. So everything that goes out from human beings is considered as black water. So usually toilets, showers, bathtubs. Things that come from the sink that's considered as a gray water. Gray water is something that you can't drink, but it's not poisonous. Okay, so you can't, even the black water is not something that you can't drink for sure, but you can't release this to the soil, really. So that's why even if we don't have the sewer system, we need a septic tank because it will contaminate the plants, and then the plants will take those substances from the soil, and you will end up eating tomato that comes from your own. Okay, it's disgusting, but we have to be careful with that. So if we release the black water to the soil, people will end up eating that because the plants will grow, and if you end up eating something that comes from this kind of water, the black water, you end up eating those bacteria, and you will have serious issues with that. Okay, so that's why we have to get rid of the black water that comes especially from the toilet. But for this one, we have to recover. So in some of the points that we get from the LEED certification is the reuse of that water. So this is not something that you can drink, but probably you can use this for watering the plants, or after a treatment, not very special treatment, we can use the water that comes from that gray water, and then we can recirculate this gray water to go to the toilets. So we don't use the toilet that comes from the city to wash the toilet. We use because we are not going to drink water from the toilet, at least not in this country. Okay, so this is not. That's good because here they have separated the black water and the gray water, but at the end, if you have the main horizontal branch and everything that, there is no separation. So now what we have to do is this. We have a sanitary sewer that comes from the toilets, and we have a storm sewer that comes from the rain. The rain is something that we can't drink directly, but at least it's something that is not as contaminated as is the water from the toilets. Okay, so we at least we have to separate the water that comes from the rain, and we have to separate the water that comes from the buildings. But even between the buildings, we can separate the water that comes from the toilet and the water that comes from the sinks. So this is getting more and more important, and in terms of having green certifications, the water management is also important. Okay, so we can't mix everything. Okay, the rain, the toilets, everything. We're going to the sanitary sewer. That depends on the town. Okay, so again, in Spain, the architects are forced to separate the black water and the gray water, but we know that at the end, and they fine you if you don't do that in your building, but at the end, everything goes to the same sewer. Why? Because the municipality doesn't have two different sewer, one from the rain, but at the end, everything is mixed. So that depends on the municipality, and probably eventually all the taxes that we pay there will be spent on this separation between the sewer, the water, and the rain sewer. Okay, but we know that in some municipalities it doesn't happen, and everything is mixed. I don't know here. I don't know the team city sewer system, but if you walk down the Winchester Street and you go to the Ashuelot River, when the water is low, you can see that there are collectors that release water there into the Ashuelot River. I bet that it's not the sanitary system, so it's the rain that is collected, and then it flows through the storm sewer to the river, and it's released directly to the river. And then what do we do with this water? We go to where do we go? Up here. we go to wastewater plants. Okay, so the drain water, the storm water can be released to the river directly. But the drainage, the water that comes from the toilet, they have to go to the treatment plant and then they can be released to the water, to the river or to the sea. Where is the wastewater plant in Kim? Interesting question.
I think behind the airport.
In the airport. Yeah, everything is at the airport. Water. In Kim. Okay, so it's a wastewater treatment facility in Kim, New Hampshire. Where is it? It's Airport Road in Swansea. Okay, so, and here probably we have information about all the treatment plants that we have in this area. But I would like to see the picture 420 Airport Road. Let's find out. Uh-huh. That's the airport. I don't know, well, probably because this is a small town, but those water treatment plants. Yeah, so there are facilities like this. Okay, so we're not going to study that because we're not engineers, but there is a lot of yeah, there are a lot of things to do, and usually they have these circular tanks. So how does it work? Before releasing water to the river, the water that comes from the drainage is we have like different pools or different tanks, and the solid particles are going down, and then the water gets thinner and thinner because the solid particles are going down. So depending on the amount of time that the water is there, there are some particles that go down, and then we can remove it, and then we can reuse those solid particles to this. Okay, so these were water treatment plants. It doesn't mean that the water that comes here you can drink it, you can, but at least it doesn't harm the water, the river or the sea or whatever. Okay, so we need this kind of facilities in every single city, and but the water that comes from the sinks or the water that comes from the rain, they don't need this kind of water treatment. And in buildings, we can have tanks and we can reuse that water. Okay, so that's the so the gray water treatment in buildings. So this is the kind of things that we, well, this is a scientific article. I want something like that. Okay. So the black pipe here, this is the black water. Okay, so it goes directly to the water treatment plant, the city water treatment plant. But within buildings, we can have smaller treatment plants. It's not that high, so that you get the magic view, but we can collect the water that comes from the from other parts of the building. We can treat it, and then we can purify that water, and then we can recirculate that water into the building. Again, it's not the water that we can drink, but we can recirculate that water to the toilets, or we can recirculate that water to water plants or whatever, because it's not harmful. Okay. So nowadays, this is required if you want to get this kind of green certificate. We have to reuse that water. Okay, so I like this view. I'm going to copy. This here. So what's this? The water that comes. Well, even from the water machine. Yeah, because of the temperature. So everything that considered like black water, we get rid of it, and we go to the sewer system, the city sewer system. What else? Here we have the drinking water. Okay, so the drinking water supplies to the sink, to the shower, or whatever. But this water, this is a gray water, so we have a tank, the technical room, and then we can purify or we can treat this water, and then we can use it for watering plants. Okay, and even here they get the water from the rain, and they get, that's another thing, the water that condensates in the split units. The water condensates there. So instead of getting rid of it, we can recirculate that water to this gray water system, and then we can use this for other units. So here we can water the plants, or we can use this for the toilets. Okay, so that would be a good building design in terms of water management. There are things that we have to get rid of. This is the black water, but the gray water and the rainwater, we can have small treatment plants in the mechanical room in a building, and then we can reuse that water, or we can use that water for the plants. Okay, so that would be the right option for buildings now, especially if we want to get green certificates and the LEED Platinum. I'm sure that there's something, there's some water treatment here in this building, because otherwise we won't have this LEED Platinum certificate that we have in this building. Okay, so this picture is not good enough, because here we have the black and here we have the gray. And at the end, we mix everything. So that's slightly better, but even better, it's this option, having in this building, having a small treatment plant so that we can reuse the water that the building generates. And then the systems are extremely expensive, and those infrastructures are serious infrastructures, because look at the size of the pipes that are running so in the sidewalk or in the street, we have this kind of huge pipes. It can be either the water or the rainwater or the black water, but that's something serious. It takes a lot of money, and doing this for a municipality, it's a huge investment. With septic tanks, you don't have this infrastructure. So again, I told you before that in Europe, septic tanks are forbidden in many countries. Here, it's something very popular, but again, live free or die. In Europe, you are not free, so the municipality has to provide you with the drainage system. And if the municipality doesn't provide you with the drainage system, you can't build the house. Period. Can I? No. But with a septic tank, no. People do it. And they're, when you are driving, you see septic tanks. They are forbidden, but they are sold. Okay, so people use it. But in the municipality, we have this. And if the city, it's something good. I told you about the galleries. So these are the underground galleries that we have in cities. So here in these underground galleries, we have the electricity at the top. We have the water, the sewer water, the black water underneath this element here. and we can have other pipes. And okay, so that this is a very good, very good system. So when we have cities like this, everything is easier, because if something goes wrong, people can be here and the gallery is big enough so that people can inspect the issue. And if you don't have these kind of galleries and something is wrong, you have to dig this and try to find out where the issue is. You have a gallery, it's better, more expensive again, but well, this is an investment that the municipality has to do once, and now it works forever. This is cheaper, so you have to dig this ditch here, you have to place the pipe, but if there's some issue, then you have to dig again and try to find the issue. So eventually, this is more expensive. This is more expensive upfront, but you reduce the issues that you have in thousands of years. If you do this, the investment is less, but you have a lot of issues and you end up paying more. But we are not deciding architects. We can't decide this. We need to understand the city sewer system, but we can decide it. And well, instead of starting the exercise, basically it's the same. Okay, so the first thing, we have this concept of the drainage fixture unit. So each fixture, it comes with a fixture unit and the minimum size, minimum trap size. So this is the pipe that goes out of the fixture. Okay, so it's the same. We have to first look at all the fixtures that we have in our building. Then we have to go to that table. We have to count the drainage fixture unit, and then it's a question of looking at the minimum size. And then here we have tables in which, depending on the fixture units, depending on the length, on the height of the stack, then we have to find out the diameter of this. Okay, so we'll solve this exercise next Tuesday. On Friday, we will keep working in Revit. You can finalize the code and how to supply, and then I'll show you on Friday in Revit how to work with the drainage system. And again, we will have to make decisions about how to get rid of this, because there's a water supply point for the building, and there's a point in which we have to get rid of the drainage and connect this to the sewer system. So we will have to make that decision in Revit again. Okay.